Number 11. What you see on the left, 3, must be an element or included in the set that you see on the right, which is true. Part B. What you see on the left is 1 included in the brackets. You do not see a 1 included in the brackets inside the set. Therefore, this is false. 6 is not a set, so it can't be a subset of 1, 2, 4, 6. So this is false. The set that contains the element 2 is an element of what you see on the right. It is exactly like what you see on the right. That's true. And the null set is a subset of every set, which is true. Summation formulas. So the formula for the summation of 1 to n of odd integers is n squared. The summation formula for 1 to n of even integers is n times n plus 1. And the formula for 1 to n of n integers is n times n plus 1 divided by 2. So we recognize 12a as having to use the formula for odd integers. So I'm needing to take 64 squared to get the answer. Part B, that would be even integers from 1 to 400. And the formula is 400, which is n, times 401. So I'm going to multiply to get that answer. Now part C says we need to take from 3 to 6 and use the rule 4j plus 2. So the first number in the sequence is 4 times 3 is 12, plus 2 is 14. Plus, then we're putting in 4. 4 times 4 is 16, and 2 is 18. Plus, 5 times 4 is 20, plus 2 is 22. And 6 times 4 is 24, and 2 is 26. So each time you can see that we've added 4 on. So 14 and 18 is 32. 32 and 22 is 54. And then 54 plus 26 is 80. So 2 of these you needed to know the formula, and then 1 of them you had to work it out. Clock solitaire, which is number 13, is not required for the online course, but I will show you the solution. So we're taking 10 and connecting it to an ace. Then we're taking 3 and connecting it to a 2. Then we're taking jack and connecting it to a 3. 9 connected to 4. 7 connected to 5. Queen connected to 6. King connected to 7. 8 connected to 4. 9 connected to 5. 10 connected to 2. Jack connected to 8. And queen connected to 5. Now, for this to work in clock solitaire, we must have connected and no cycles, which we do. We have ace to 10 to 2 to 3 to jack to 8 to 4 to 9 to 5 out to 7 and king, or to queen and 6, and so we would win if these were the bottom cards in a game of clock solitaire. Again, not required for the online course. Number 14 is the art gallery problem. Again, not required for the online course. So we triangulate this figure, divide it into sets of triangles, and then we put a 1, 2, and 3 at each one of the vertices. So each triangle then has a 1, 2, and a 3 in it. So we have 1, 2, 3 in this triangle, and so on all the way around. And what we're looking for is the number of sides, which is 10, divided by 3 floored. That is, get rid of any fractional part. And we're looking for 3 of the same number. So we could place the cameras at the 3s, and we'd be able to view all of the artwork on the interior walls of the art gallery. Steiner, again, is not required for the online course, and all it's saying is that there is a point called the Steiner point with a construction such that if I formed an equilateral triangle here and found a point, that I would connect that back to the opposite vertex and so on, placing a point here, again an equilateral triangle, and connecting that to the opposite vertex. That's how we find the Steiner point. And the significance is that the distance from S to A plus the distance from S to B plus the distance from S to C is always less than the sum of the two shortest sides of the triangle. So S to A, S to B, and S to C is always less than the sum of the three shortest sides of the triangle. The RNA reconstruction also is not required for the online course, so I'm hyphenating between the C, U, and the G. So I'm going to make a graph that goes from C to G with U on that edge. Then I hyphenate after the C, C to AC. And I don't hyphenate at all in the last segment. There is no C or U. Then I hyphenate after the G in the next column and go from AA, G to C, and hyphenate after the G, go from G to C, and I don't hyphenate in either of the last two because there's no G. So to follow the arrows, I go from A, G, and to C, then with a passover of U, go to G, back to C, and then at AC. So that if I break after every G, I get an AAG, a CUG, and a CAC. If I break after every U and after every C, I get an AAGC, a U by itself, a GC, and an AC, and I know this is the reconstruction given the G column and the UC fragment column.